Hi and welcome to Bytes and Bits. Thermal cameras are a really useful piece of equipment to have in your electronics toolkit. They allow you to see heat, and again, for electronics, that becomes very useful. So things like failing ICs, short circuits, overcurrent devices, and so on. Most of those sort of problems that you'll have in your circuits will end up either generating excess heat, or if a device is not actually receiving any energy, then of course that will not generate heat at all. So being able to see that quickly with a thermal camera can really help you sort of narrow down where possible faults in your circuit may lie. So in this video, we're going to have a look at this one here from Thermal Master. This is their P3 thermal camera, which is a really good device. And it has some special features which make it particularly useful for electronics diagnosis. Again, as well as all of the other things you can do with a thermal camera. So let's see what you get and what it can do. So priced at around about $280, the Thermal Master P3 is a high-resolution thermal camera that connects to your smartphone or your PC using a USB connector. So let's have a look at what you actually get in this box. So first off, you get the actual camera itself, and that comes in this really nice transportation case. So that, of course, protects it from any damages. It fits nice and snugly inside this sort of foam padding area. So this is the actual camera itself. And as you can see, it's a nice small unit, which is obviously quite robust. And it connects, of course, to your smartphone by plugging into a USB-C connection over here. You also then get with this. So this does work with both Android and iOS devices. So you get this USB-C to Lightning adapter, and that simply then plugs in the top there, and that lets you then plug it directly into your iPhone or any iOS device. You also get then this second lead here. So this lead is very, very useful actually. So this allows you to connect your P3 camera. So the P3 camera goes in at this end here. It plugs in there. And then the other end of that then, you can either plug that into your mobile phone through a USB-C port here, or you can use this built-in adapter. So you can simply plug that on there, and you now have it plugging into a normal USB port, and that allows it then to connect to your PC or some sort of computer anyway. The good thing about this one then as well, of course, is that we now have, once we have that plugged in there, this end will be plugged into whatever it is we're monitoring it with, or a phone, whatever, and we now have a camera that we can really just move around as we want, and that really helps us then get into those sort of little nooks and crannies, just to get some really close-up detail on the various devices and components that we want to look at. As well in the box then, you also then get a manual, and this of course takes you through the various sort of setup and so on with the device, where to get the app. So if you're using this on an iPhone or an Android device, you will need to download the Thermal Master app, and that gives you all of the features then for actually sort of monitoring, taking your measurements, and of course recording what you're doing. So that's what you actually get in the box. So let's have a look at the specifications, and then we'll actually plug it together and have a go with it. So if we look at the specifications then for this camera, so this is a thermal camera. It uses a vanadium oxide detector, which is fairly standard for these ones. It gives a better stability on the image. So that detector has a native resolution of 256 by 192 pixels. Now, if you're familiar with sort of optical cameras, that doesn't sound like a very high resolution at all. But in terms of thermal imaging, and especially at this price point, that is actually pretty good. The sensor itself then, the pixels on this detector then are 12 micrometers in size, which again gives it then a much finer detailed image when we come to actually look at that. Now the system does have some software enhancement of the image, so they have this X3 system which they use on Thermal Master cameras, and that effectively then it doubles the dimensions or quadruples the resolution of the image itself. So that goes up then to 512 by 384 pixels. So in terms of temperature range then, so this sensor can detect temperatures between -4 Fahrenheit up to 1122 Fahrenheit, or if you're over here in the UK, that's 20 Celsius, or sorry, minus 20 Celsius up to 600 Celsius. And that is with an accuracy then of plus or minus 2 Celsius or plus or minus 2%. Again, the accuracy then will of course depend on what temperature range you're looking at. Now, stability of the camera. So at room temperature, that is less than 35 millikelvin. So again, this NETD figure, it really gives you an idea of the quality and stability and sort of the noise that's inside the sensor itself. So that is a nice low level to give us a nice steady, accurate image. Now, as we've seen there, there is this manual focusing ring on the camera, and that really comes in handy when we want to get in really close. So it doesn't have autofocus, and it's not a fixed focus lens. So that does mean then that if you are far away from an object, you will have to, of course, use that manual focus just to get that image nice and sharp. But it does then, as I say, when we get in close, there's no issues with autofocusing at very close range. You simply use that manual focus and you can then get really sharp images. And again, we'll see that in a second when we actually use it on some surface mount circuitry. Now, as well as moving the camera closer and further away, we do obviously have then some digital zoom. So there is up to 15 times digital zoom, but of course that does still work within the normal camera resolution. So as you zoom in, you're not actually creating any extra pixels or detail in that image. You're simply then making each of the individual pixels bigger on the screen so you can see it. But again, with that sort of enhanced resolution, pretty much as you use your digital zoom, you will have a number of pixels on each component, even the very, very small surface mount components. You will have a number of pixels on that component so that you can get a more accurate temperature reading from it. The refresh rate then is 25 Hz, which is pretty good for cameras in this price point. So again, you want to have a nice smooth image as you're moving around and not have to wait for it to refresh itself. So again, 25 Hz, that is absolutely fine. And then power consumption then is only 0.32 watts. So that does make sure then that it doesn't drain the battery in your phone very quickly. So you can use this for a few hours, again, if you have a sort of reasonably good and well-charged battery. So again, you should be able to do everything you want without having to worry about recharging in between. So that's the general specifications of it. So say this is a very good set of specifications, again, for this price point. The resolution, of course, is one of the main things that we want for our PCB fault finding and so on. So that high resolution and the ability to get really close with that macro focusing, that is what's going to set us apart from other devices. So let's actually get a circuit up and running, plug this together and see what it actually performs like. So I've now got my camera connected up to my phone here. And again, I'm using this extension lead so that I can just simply move it around and show you different bits of this little circuit down here. So the circuit I've got is actually a Raspberry Pi Zero, and this is actually running a MAME emulator, and it's one of the little circuit I've been using recently for my sort of arcade game setup on your TV, just using a Raspberry Pi Zero. So that's what we've got. So it is actually doing things at the moment, which gives us then a bit of temperature reading coming off the system. So I've got my phone, obviously, that has got the Thermal Master app loaded in, and you can see here that we have our interface for this particular app. So again, I've got my camera and I can line that up. The good thing about this focusing ring then, of course, is that we can really get both our distant views. So again, I can come up here and I can, let me just get my hand out of the way for you there. I can refocus that to get us a nice clear image of what we're looking at. And again, as I go zooming in, you can see that we come out and we can then, of course, then refocus that to get a close-up image. But if I come out a bit, just so we can see generally what's going on. And there we are with our image. So again, with the interface then, we can start to do a number of different things with it. So at the moment, I've got the actual image itself on the screen is upside down, if you think about that. So we've got our connectors coming out the top on the actual device, but they're coming out the bottom down here. So if I go into the sort of settings area, I can then just rotate that round so that we now have it matching up with what we're looking at. And again, it's because I'm sort of holding this camera in different orientations. It's not always matching up with what's coming up on the screen. So let's put it to there. Okay. So on screen now we have a set of colors. Again, we can then play around with that. So there are different ways of looking at the color information. So you can see here we have a range of different, in effect, sort of color interpretations. So again, I've got the rainbow, which gives us this multicolored effect for our system. We've got other things, the jungle aurora, and so on. There is one at the end here, which is sort of labeled as medical, and I'm suspecting that's sort of what we're more used to seeing as regards sort of thermal imaging, where we have all the different colors on there. Some of them, of course, are better for our electronics. So if I come down here and we go to red hot, this is quite useful for spotting hot points in your circuit board. So it really just takes away a lot of the color and thermal information, and then is only pinpointing the hottest areas. So you can see here at the moment then that we have a hot area here for our main sort of processor, and a couple of hot areas down here, which I think are sort of part of the power circuitry and so on. So that gives us a range of ways in which we can visualize our color information. So if I come back onto rainbow, it's simply because it gives you sort of a more interesting picture. Once we've got our system all plugged in, we can, of course, then take measurements. We have our temperature measurement area over here. So if we do that, we can then sort of select various ways in which we want to measure that. So I can pick out points. So I can say I want to put a measurement point pretty much in the center of where we are. And you can see there it's labeled as P1. And up the top here, then, you can see that P1 is currently sensing, oh, I've just put one in there, haven't I? Let's just do that again. So P1 in the center, and you see that P1 is now measuring 48 degrees. So what I can do here is I can just simply move my sensor around, and you can see the actual CPU temperature there is at 56. So again, we can sort of measure various parts of our circuit that way. We can then use various line tools. So if I do a line, I can do a line across the system. So let's see if I can do that there. And you can see we now have a line. If I move it onto a lighter area. And what the line 1 then does, it basically tells us what the maximum temperature across that line is, what the average temperature, and so on. So if I was to put that across my circuit board here, you can see that it would be sort of measuring hottest point is, of course, going to be that the processor in the center there, and then, of course, either side of it, then we have different ways of different measurements of temperature. Again, these different ways of measuring it, then again, for different applications, you would use those. For our circuit board measurements, mostly we will be using the point. So let me just clear that and put a point then back sort of in the center. So again, what we can now do, of course, then, when we're sort of viewed out at this sort of level here, it's hard to identify individual bits, but we can basically see then that our CPU is obviously running and doing something, but we have then some other areas over here of hotspots, which we could maybe get a bit of a closer look at. So if I sort of zoom in on those, so again, we've lost our focus, but if I then readjust this, we should be able to get that back into focus if I turn it the right way. And there we go. So we can bring everything back into focus. And you can see now that we're looking at some of these very small sort of components down here, capacitors and resistors and so on. We now have our hotspots here on these ICs. So let's see if we can go in a wee bit closer on that. Can we get any closer? Let me just put it into its most zoomed in level. Okay, so we'll get about that close there. And you can see now we've got some little small ICs over here. And again, we're measuring that one then at 49 degrees. This little IC over here, we're measuring that at 48. So again, these particular ICs then obviously are handling power at the moment and dissipating heat. And that gives us then our hotspots. A lot of these bits over here, so we have various capacitors and resistors up here. Again, if any of those were failing or being overloaded or shorted out or something like that, again, we may well see hotspots appearing there on those particular components. And this is how the thermal camera is a really good aid for very quickly identifying where there are potential problems in your circuit, simply by looking at the heat dissipation in effect. In effect, that's what this is telling us, is energy dissipation or energy loss, or lack of energy will of course result in different temperatures in those components. But that then is our camera. And as you can see, we can get very fine detail. So this manual focusing then allows us to go in very close and really see the detail level. And that is one of the big things about this particular version of it, where it does have this manual focus. Some of the auto-focusing ones, you're sort of ending up, getting to about sort of this sort of level of view, and then having to use the digital zoom to get in and go closer. And you can see there we start to get pixelation on these. So even though we're running, I'm actually running it, this is X3 mode up here, is its high resolution mode. So it actually takes the sensor information from the camera and uses digital interpolation for that to increase the resolution. You can see even at that, we're getting very pixelated here. But of course, if on our one here, we can of course go back out to our one-to-one view. If I get down to one-to-one and just simply go in, and then of course we can use our focus to really focus in very, very close and get some close detail. And again, we can still, once we're zoomed in, of course, then go in a bit more with our digital zoom. So that's our camera showing you then with circuit board problems, where we can really just use that to help quickly identify various areas what we maybe need to look at a bit deeper once we come to actually do our proper fault finding. So in terms of a thermal camera for electronic circuit fault finding, I would have to say, out of the ones I've used so far, I've used a few of them now, this would be the one that I would choose for that particular application, particularly this being able to get really in close to circuits, especially for some very intricate small circuitry where we've got some very, very small resistors and so on. This is a real boon to be able to go and see those and get some really good temperature readings from them. But obviously a thermal camera can be used in a number of applications. So I actually did have to use it this week as well. So we had a bit of a draft coming in. So this is in our bedroom. We're looking at the bedroom window and we're getting a little bit of a draft coming through in there, feeling a bit of a cold air coming in. So again, using the thermal camera, you can see that we have a break in the seal just down in this bottom right hand corner. You can actually see that coming up here in purple, and that is again, if you look at it a bit more closely in real life, you can actually see there is the silicon seal is not touching against the frame, so that is letting some draft coming in through there. So again, you can really see it coming up on this particular image. So I will obviously have to do something about that. We also then had a little bit of an issue where we'd been replaying with the temperature on our hot water system, but it wasn't quite getting enough hot water up to our shower area. We just refitted a pump, and that had a specification for the maximum water temperature, which we're trying to sort of keep it down to. But again, this let us see then that we were actually getting hot water flowing through. It's just that it wasn't hot enough to actually do what we wanted it to do. So again, some really good applications, and again, these thermal cameras, it's amazing how many different application areas you can find them use in terms of your car, your home, your electronics, and so on. So really useful device to have. As I say, I'm really impressed with this Thermal Master P3, and I say especially in terms of using it for our electronics projects. So that then is the P3 thermal camera from Thermal Master. And as I say, it's a really useful device. And as I say, the electronics capabilities of this are about the best I've had to go with so far. So I do really highly recommend it. Again, I'll put links to that down in the description of the video. And I think at the moment, as they make this in October 25, they have got some special promotions on at the moment. So do check out their website to see if you can get hold of one of these at a really good price. So I hope you enjoyed this video and you found it useful. Please do click that like button and subscribe to the channel for more sort of electronics, making projects, gaming, and of course console modding. I look forward to seeing you again very soon, and bye for now. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.